Okay, so let's say you have memorized the equation for mass moment of inertia of component of common bodies. Okay, you know the equation, but for each and every simple component. But now we have a combination of several simple components, make it a composite bodies. How to calculate the mass moment of inertia of this one? For example, if the question asks you to calculate what is the I x for the whole composite bodies. Okay, so the way you need to do is you have to first identify simple or common bodies. Okay, let's say in this one we have 1, 2, 3 road. So let's say we name it the first component, the second row, and the 3 road. Identify and put it in simple way so that the component that you already have or memorize the equation. And then you have the fourth component, which is the semicircle. Okay, fourth component, and minus, this is the whole. Okay, minus this one is the fifth component. Okay, so to make this rigid body, you have to add 1, 2, 3, and 4 component, and you have to minus the last one, the fifth component, and then you have this component. So your I will be combination. So the Ixx of for the whole component will be the Ixx for first one plus Ixx for the second one plus Ixx for the third one plus Ixx for the fourth. And because it is we put away this component, so minus. Okay, if we put away we minus, if we add up, so we have to add Ixx of the fifth component. So you have to go make it one by one. The first one, you make an equation, come up with the equation. You have the one value, second one, 4, 3, 4, and last one, and you add up all together, you have the answer. So same goes to Iyy and Izz. So Iyy, y1 plus I, y2 plus I, y3 plus I, y4 minus I, y5. Calculate one by one, add up together, lastly you have the answer. Okay? Okay, so we are now in the last part, which is parallel axis theorem. Okay, so the equation is IAA equal to IGG plus MD squared. One simple equation. Okay, so but you have to memorize that this IAA can be anything. Okay, can be IBB, can be IXX, IY, IZ, and so on. Okay, meaning that this is the location the question asks you. Calculate the mass moment of inertia towards axis AA, BB, XS, YY, and so on. But the IGG must always pass through center of gravity. So this IGG is the mass moment of inertia that pass through center of gravity parallel to the one that is asked. Okay, parallel to AA. Okay, and then M is the mass of the component. D is the distance from the A, if you want to IAA, from the distance from this line toward this line. Okay, so in your book you see that the D is perpendicular distance between AA and the GG axis. Okay, the distance between these two lines. Okay, if it is a simple component, it is easy to measure or see the D, but if it is a complex one, you have to. Later on, I will explain how to get the D so that you don't make a mistake during the calculation of T. Okay, so let's say we have this problem. Okay, so it is likely the same as what we have memorized. Okay, from the common component. Okay, but the difference is now my component is put in the way that the center of gravity is no longer in X and Y axis. Okay, no longer in the middle of X, Y, and Z axis. So if I want to calculate I Okay, I y y. What you already memorized is I y y equal to ml squared divided by 12. Okay, now this is the one that you remember, I y y equal to 12. So if you directly use the equation here, this will be wrong, because this I y y valid using this equation if this y y pass through center of gravity. Now our y is not go through center of gravity. Okay, so we have to use this equation. So I y y equal to I g g plus md squared. Okay, you have to apply what is you already know. So in this case, I y y is this location. Okay, I g g is this location. Okay, so the one that you already memorized is actually the I g g at the same direction with the y. Okay, so your equation will be, if you look at from y direction, what you will see is you see from y direction, you will see a road. So you will see this one. Okay, so your equation will be, now I y y equal to, looking from that one, you will have ml squared divided by 12 plus m d squared. Okay, because the one that you remember is at the center of gravity, not the y. Okay, so that's why you have to understand. Same as if you go to z direction, you will have izz equal to igg at the same direction of z plus md squared. If you go to x direction, also same. Okay, so this one I can say that it is also same as this one, same as izz. See, same condition as z. Let's see if you have from x direction. And okay, so the last one is, what is the value of b? So before we go that, we go to x direction. So now I want to have the I xx. Okay, from what you have read, you looking from x direction, you will see this one. So ixx equal to 0, which in this case it is wrong, or might not be wrong, depend on the situation. So what you need to do is, okay, this one, what you need to do is, what you memorize is this part. Okay, so in this way